So now what we're going to do is we're going to use our formula weight to calculate the percent composition. So the percent composition is going to tell us what percent of the weight is composed of whichever element we'd like to find that percent for. So if we take a look here, we have sodium fluoride, and we have one atom of sodium, one atom of fluorine. We multiply by our atomic weight, and we get the formula weight. So now what we can do is we can take that atomic weight of our sodium atoms, and we divide them by our formula weight and get a percentage. So we have our 23 atomic mass units times 1 divided by our overall formula weight times 100, and it gives us 54% sodium. Likewise, we have 19 AMUs of fluorine times 1, because there's only one element, one molecule, one atom there, and then divided by the total formula weight times 100, and we get 45.2% fluorine. Okay, so let me click over here, and I'll show you all how that's done. Alright, so we have a brush here. So in sodium fluoride. Okay, so we're going to find the formula weight first. We have one atom of sodium. And jump over here to the periodic table, and we can see sodium here at 22.99. We'll just call it 23. Alright, so our formula contains one molecule of sodium times 23 atomic mass units. So the total amount of sodium is 23 atomic mass units. For fluorine, again we have one atom of fluorine in each molecule. We're going to look up that molecular weight, 18.996. We'll just call it 19 for simplicity. So 19 atomic mass units. So that's going to give us 23, and this is going to give us 19. And then our overall mass, 9 plus 3 should give us 12. And then 4. So we're looking at 42 AMU for a total formula. Alright, so now we want to find the percent. So the percent of sodium is going to be 23 AMU divided by 42. So 23 divided by 42. We can use our calculator now. And we get 54.8%, or 0.548. If we multiply that by 100, we get 54. That's a terrible looking for. Let me fix that. Alright, so 54.8 percent. Okay, same thing with fluorine, only we're going to use the total amount of fluorine divided by the overall formula of mass. So 19 divided by 42. So let's go back over to your calculator. 14 divided, alright. 19 divided by 42. And that's going to give us 0.452. Or 45.2. %. Okay, so that's all there is to it. Let's jump back over to our PowerPoint. Alright, now we're looking at chemical reactions themselves. So chemical reactions occur through the formation and breaking of chemical bonds between atoms. So anytime we have a molecule and we break those bonds or form new ones, that is a chemical reaction. It changes the chemical properties of the material. When we have a chemical reaction, we know it because the matter has changed. We create new materials, and there's an energy exchange. Often we'll find that reactions heat up. They become hot and give off heat energy, light energy, sound energy. Or we might see that some chemical reactions get cold, meaning they're taking energy in from the environment to have the activation energy to cause the reaction to proceed. So we use chemical equations to represent those reactions, and they are nice, concise representations of those chemical reactions. Right, so each chemical equation has some different parts. We have the reactants, and the reactants are what exists before the things react. Okay, so that's what we're putting together or taking apart to produce the final substance, which is our product. So the product are the substances that exist after the reaction. So we can express this with words, but that doesn't really tell us as much as we need. So we're going to use symbols and formulas, and we can use those for quantitative purposes. So we have our reactants on the left-hand side. We have an arrow that says the reactants produce whatever's over here. So reactants produce product. So carbon plus oxygen produces carbon monoxide. Well, it could be carbon monoxide, it could be carbon dioxide, it could be a whole host of things. Okay, so that's why we need the symbols and the subscripts to show us how things are occurring quantitatively. Okay, so here we have carbon plus oxygen as a diatomic molecule, because that's the way we find oxygen. We put those together and we get CO2. But that's not carbon monoxide, that's carbon dioxide. So what do we do with that? Well, carbon plus O2 is going to give us carbon monoxide. Well, we've got to fix this because we have one carbon here, but we have two oxygens here and two oxygens here. So we lost an oxygen somewhere in the process. Well, we didn't really lose it. It's just not represented the way we need it to be represented. Okay, so now is when we start balancing those equations to show how the different elements react and how they go together in different quantities, and they maintain the same mass of products as the same mass of reactants. Okay, so I'm going to end this section here, and then I'm going to start a new video, and we'll jump into balancing those equations.